So,
Yes.
ma'am.
Okay. Sure. Now we will start for the second semester. First, we will go for the syllabus. That what is the syllabus for the second semester? There are four chapters. That is matrices and determinants up to the order of three only. Matrices orders 3 by 3, 3 by 4 by 3, 6 by 3. अशा बऱ्याच असतात. But for your examination, there are only up to the order of three. We will see what is the matrices and determinants. Then second chapter is linear programming problems. It is called as the LPP. It is up to two variables only. Then correlation and regression. Most of the part of correlation regression is covered in the SD, standard deviation, right? So remaining part is just what is the line drafting and all. We will see in a correlation and regression. And the last one is index numbers. Okay, so there are four chapters for the this second semester. Now, first one is matrices and determinants. For this, we will see the definition of matrix, types of matrices, then algebra of matrices. Algebra, it means how you will add the matrices, how you will subtract the matrices. Then what is the multiplication and division of the matrices. Then determinants. Determinants is the value of matrices. You have to calculate the value of total matrix which is given for you, and you have to determine the value of particular matrices by multiplication, addition, subtraction, or division, whatever the applications are given in your question. Then adjoint of a matrix, we will see this. Then inverse of a matrix via adjoint matrix. And homogeneous system of linear equation. It means with the help of matrices, we can draft the linear equation also. So we are going to see the same also. Then conditions for consistency of homogeneous system. Then solution of non-homogeneous system of linear equation. So here maximum three variables are applicable. Why three? Because you have a matrix solution of matrices only up to the order of three. That's why we will see the linear equation up to three variables only. The last one is second last is applications in business and economics, and we'll go for the examples and problems. Then second topic is linear programming problem, that is LPP. It is we will see the definition and terms in LPP. What do you mean by linear programming problem? Then what is maximization? What is the minimization? What are the variables? How you will determine the equation, right? So we'll see this in a LPP. Then formulation of LPP, how the LPP, that is linear programming problem, how you have to formulate this problem with the given information. We will see the same also. Then solution by graphical method. Now for the MCQ type, they didn't ask you for the solution, but they will give you the details of the LPP, and you have to define that which graph is perfect for the LPP. So we will see the questions like this in our lecture. Then examples and problems on LPP. It's the smallest chapter in all four chapters. Then correlation and regression. In correlation and regression, we'll see the concepts and types of correlation. Then what is the scatter diagram? So scatter diagram, it means when we plot the variables on the graph with x and y axis, we'll get a specific design of graph. So with the help of this design, we define which type of correlation between these two variables. So with scatter diagram, we'll see the correlation. Then what is the interpretation with the respect to magnitude and directions of relationship. It means in which direction these variables are moving. With the help of this, you have to define which type of relation is there within these two variables, two or more variables. Then we'll see Karl Pearson's coefficient of correlation for ungrouped data, and the Spearman's rank correlation coefficient with tie and without tie-up. So these two, all this Karl Pearson and this Spearman, right? These two are used for the correlation coefficient. So for the first term, we'll see these two principles or two formulae. And the last one is concept, regression, right? So for regression, we have to draft the lines of regression for ungrouped data and predictions for using the lines of regression. Then regression coefficients and their properties. So without proof, it means in the real life, we have to prove the regression lines that whatever properties you have to draft, whatever properties you have draft through the regression lines, you have to give a sufficient proof for this. But for the US study, without proof, we are going to see the regression coefficients and their properties. The last one is examples and problems on correlation and regression. And the last chapter is index numbers. Okay, so index number is the concept of index numbers, price index number, then price relatives. So there are types of index numbers also there. So we'll go for the index number types also. So problems in construction of index number, it means how we have to construct index number. What are the problems we face while constructing the index number, and what are the construction of price index number. Then in price index number, there are better index numbers, last first name, partials and features method. Then second part is cost of living or consumer price index number. So in cost of living and consumer price index, we'll see a definition, then problems in construction of such consumer price index number. Then what are the methods of construction? So last one is family budget. This is also asked many times, that family budget and aggregate expenditure. So it is a part of index number only. So when we'll go for this index number chapter, we'll clear this concept. Then what is the inflation, then use of index numbers and commonly used index numbers. So what are the index numbers commonly used for the purpose of data analysis, such as the happiness index number is there. So it is one of the index which is calculated worldwide. Then family index number is also calculated. Then family budget is index number is calculated. Gross, that is GDP. GDP index number is calculated. Then per capita income is calculated. So these are the types of index number which are actually used in the overall world. Okay, and we'll see examples and problems on the index number. Now this is a syllabus for the second semester. We're going to see. So there are 4 chapters. Out of these 4 chapters, we'll go for the whatever available data or whatever available situation right now, that is in MCQ pattern. So we'll go for the MCQ question answer session also, as we have conducted in the first semester, right? So we'll go for the first chapter now. That is matrix. Okay. In singular form, it is called as matrix, and in multiple, that is plural form, it is called as matrices. So what is a matrix? So matrix is a set of m into n numbers, m by n m by n numbers arranged in the form of a rectangular array having m rows and n columns. So m determines the row and the n determines the columns. It is called as matrix of order m by n. So whenever you have to write, or whenever the question is asked that what is the order of matrix? So for order of matrix, you have to write m into n, m by n. That is, first you have to take a number of rows and then number of columns. Just see the let's see the example. So it is one of the matrix A is equal to A, B, C, D, right? So it is a formula for it is a format of matrix. Matrix is always done in rectangular or circular bracket or single lines also do. Here N, right? These are the rows. These are the rows. So row elements are A and B for the first row, and C and D for the second row. So there are 2 rows, right? And columns will be this one, N. So there are also 2 columns, that is 1 and 2. So this matrix becomes of order 2 by 2. Just remember it. So these are rows, and the verticals are your columns. Now, so these are matrices. A is a matrix of order 2 by 2. That is 2 rows multiplied by 2 columns. So it is called as a order 2. If the rows and columns are same, that time it is called as order of 2 only. Okay, why? Because rows and columns are same, so you don't have to write the 2 by 2. Just write it as a order of 2. So it means it's a square matrix with the 2 of 2 orders. And here A, B, C, D are certain numbers. There are numbers given, and these are called as the elements of matrix. These are necessary. So it is a matrix. This one, right? So whole set is called as a matrix. These are called as rows, and these are called as the columns. Okay, and A, B, C, D, these are called as the elements of matrix. Now, what are the types of matrices? Because this is asked in the MCQ also. So they may give you one example of matrix in your question, and they will ask which type of matrix is this. So types of matrices are null matrix or zero matrix, then row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, then unit matrix or identity matrix, then upper triangular matrix, lower triangular matrix, symmetric matrix, and last one is antisymmetric, or it is called as skew symmetric matrix. So these are the types of matrices we are going to check out. So will you get the definition of matrix? Matrix ची definition समजला, matrix समजला काय आहे? If anyone has difficulty, let me know. रोज आणि कॉलम समजलं. सो आडव्या ज्या असतात त्या रोज असतात आणि वर्टिकल ज्या उभ्या असतात त्याला कॉलम्स म्हणतात. ओके, याच्यामध्ये इथपर्यंत तुम्हाला काही डिफिकल्टीज आहे कारण की त्याच्या बेसिसवर टाइप्स आहेत. सो त्याच्याप्रमाणे आपण बघणार आहे. इज देयर एनी डिफिकल्टीज? You may reply to the chat box also or unmute yourself whenever you are comfortable. Okay, is it okay?
बोल.
Okay, ठीक है, thank you मम्मी. Now we'll see first type of matrix, that is null matrix or zero matrix. Now zero matrix is called as a matrix whose all elements are zero, right? So in given matrix, if every element is zero, all elements, if all elements are zero, it is called as zero matrix or null matrix. It is always denoted by O, capital O. It means it's a zero matrix. You have to remember this, currently specific, there are 2 or 3 types of matrices which are defined specifically by specific alphabet. So for zero matrix, it is always denoted by O, capital O. So let's see the example. Now see this one, right? It's a single row but all elements are zero. Then it's a 2 rows and 2 columns. So it's a 2 by 2 matrix, right? So matrix order is written at the right side corner. So it's a 1 by 2. 1 row, 2 column. This is 2 by 2. 2 rows and 2 columns. And all elements are 0. Then again 3 by 3, right? 3 rows and 3 columns are given. All these are 0. So it's a 0 matrix. Then it's a 2 by 1 matrix. That is 2 rows. Here there are 2 rows and 1 column. So it's a 2 by 1 matrix. Okay. And all elements are 0. Then it's a 3 by 1. That is 3 rows and 1 column. All elements are 0. So it is also called as a zero matrix. So zero matrix, it means all elements in a matrix are 0. Then it is called as a zero matrix, and it is always denoted by capital O. So O is equal to, then you have to write this matrix, then it is a zero matrix. Now next is row matrix. Row matrix, it's a matrix having only one row but may have many columns. Okay, row matrix are it rows, only one row, single row is there, but columns may be more than one column, and it is always in an order of 1:1. Why 1:n? 1, it means first is your row, right? It's a row column. So why in row matrix it is always 1? Only single row is there, so 1. Why? Number of columns you have to define. So here let's see the example. So first one 1 0. It's a order of 1 by 2. Right, 1 by 2 order आहे, so it's a single row. It's a row matrix. Then let's see second 2 5 7. Right, it is also order of 1 by 3. It is also a having single row but have a multiple columns, so it is also a row matrix. And then A B C D, right, it is also having a 1 row only and there are 4 columns, so it's also the row matrix. These are types of row matrices. Now column matrix. Now for column matrix, let's see. Same, it's a reverse of row. Row la kasa asta, only single row is there and many columns. So for column matrix, there is a single column and many rows. So a matrix having only one column but may have many rows is called a column matrix. For column matrix, it is always n by 1. N by 1 it means the column must be the one only and the number of rows may be as per the matrix is given. So let's see the example. So first one, let's see this one, right? 0, 1, 3. So there are 3 rows but 1 column, right? So it's a column matrix. Here same -4, 5. So it's order of 2 by 1. So row are 2 but column is only 1. So it is also column matrix. Then this one ALMP, right? So there are 4 rows and 1 column. So it's also column matrix. Next is rectangular matrix. Now with the shape of matrices, 11th shape of matrices, you will get this type of matrices. So a matrix having unequal rows and columns is called a rectangular matrix. So it's a unequal row and column. It means number of rows and number of columns did not match with each other. It means M is not equal to N. In such type of matrix order, M is never equal to N. M म्हणजे काय rows आणि N म्हणजे काय columns. So M is never equal to N. So here, for example, this one right here, there are 3 rows. 1, 2, 3 rows, right? But 1 column. So it doesn't match. But it is also called as a which type of matrix? Row or column? सांगा बरं हे कोणतं मॅट्रिक्स येईल अजून रो येईल का कॉलम मॅट्रिक्स येईल?
Column.
Yes, right. It's a yes, it's a column matrix. Why? Because there is a single column. Now this one, right? Second, see the second example. There are 2 rows are given, right? These 2 rows and 3 columns are given. So these are not equal. M is not equal to N. So it is called as a rectangular matrix. Let's see other. There are 3 rows and 2 columns. So it is also there is no M is not equal to N. So it is also called as a rectangular matrix. Now second part is square matrix with it's a reverse of rectangular. In rectangle, what is it? M is not equal to N. It means number of rows are not equal to number of columns. But in square, जसं आपण स्क्वेअर काढतो बघा, राईट? सो स्क्वेअरला काय असतं? ऑल अँगल्स आर इक्वल, right? But in rectangular, there is no, only both sides face to face sides are equal, other sides are all sides are uneven, not equal with each, not match with each other. But in square, all 4 sides are matched. It is called as a square. So same logic is here in square matrix. When number of rows are equal to number of columns. So a matrix in which the number of rows is equal to number of columns is called a square matrix. So for square matrix, in such type of matrix order, M is always equal to N. So number of rows always match with your number of columns. So let's see the example. See 4, 5, 9, 2. So there are 2 rows, right? So these are 2 rows and 2 columns. So it's a square matrix 2 by 2. It is called as a matrix of order 2 or 2 by 2. Then this one 1, 2, 3, 4, 5, 9, 6, 7, 8, right? So it's the order of 3 by 3. While reading the matrix, you have to read with respect to rows only. Huh? The rows sequence you have to read it. Why? Because you have to order with the rows sequence. So when we go for the addition or deletion, addition, subtraction, multiplication or division. For this, we have to know that how to read the matrix. So for matrix, we always read with the row first. Then we'll go for the column. So row 1, 2, 3, 4, 5, 9, 6, 7, 8. So there are 3 rows and 3 columns. So this is a order of 3 matrix. So when there is a number of rows are equal to number of columns, it is called as a square matrix.
Square.
Now, diagonal and non-diagonal elements. Now, the next type is on the basis of diagonal and non-diagonal elements. So we have seen the elements, right? So elements are these are, for example, this is a matrix 4, 5, 6, 7, right? So these are the elements of matrices. On this basis, these are divided into diagonal and non-diagonal elements. So let's see what are the diagonal elements and what are the non-diagonal elements. So for example, this is a matrices are given 1, 0, 5, 6, and the another one is 9, 2, 3, 4, 5, 9, 6, 7, 8. Always remember, diagonal and non-diagonal elements are classified only in the case of square matrices. Square matrices, it means where a number of rows and number of columns are equal. So this is this first one, right? So first one जे आहे this one, it is of order 2. So 2 by 2 आहे, 2 rows 2 column आहे, so it's a square matrix. Here 3 rows आहेत आणि 3 columns आहे, so it is also the square matrix. Only in case of square matrix you can define the diagonal elements and non-diagonal elements. Okay. So here, now you will see what is it, 1 and 6, right? It's a diagonal. So these elements are called as a diagonal and remaining elements are called as a non-diagonal. So element 1 and 6 are called as diagonal elements, and in this case other elements which are this 0 and 5, right? So these are non-diagonal elements. So for this now, for the second, this matrix 3 by 3 matrix, so diagonal will be this one, right? So let's see. This is a diagonal. It means 9 by 8. These are diagonal elements. Okay, and the remaining are non-diagonal. That is 2, 3, 9, 4, 6, 7. These are the non-diagonal elements. Is it clear?
Yes, ma'am.
Is there any difficulty? Okay, thank you. So here, with the help of this, we can define the next type. So now next type is diagonal matrix. So diagonal matrix, it means a square matrix. Always remember, diagonal is always defined with the help of square matrix only. So in square matrix, in which all non-diagonal elements are 0. Non-diagonal, only non-diagonal elements are 0 is called diagonal matrix. Here we have taken all non-diagonal elements are 0 is called as a diagonal matrix. So let's see the example. So here, this one, right? So non-diagonal elements are 0, 0, right? This is order of 2 of 2. This one 3 of 3. This is a diagonal. This is a 1 by 8. This is a diagonal, right? And non-diagonal are 0, 0, 0, right? So all other non-diagonal elements are 0. So it's a diagonal matrix. Same here. Take out 409. It's a diagonal, but other elements are 0, right? So it's a diagonal matrix. In short, how you have to remember, diagonal matrix diagonal elements non-diagonal elements are, these are always 0. It is called as a diagonal matrix. And now reverse of it, that is scalar matrix. So scalar matrix ka hai? So it's a diagonal matrix in which all the diagonal elements are equal. Now see, it's a diagonal matrix. Diagonal matrix म्हणजे काय? Square matrix where non-diagonal elements are काय? 0 आहे, right? पण मग diagonal element ज्याच्यामध्ये diagonal matrix मध्ये diagonal elements are equal, all equal, जे पण diagonal आहेत ते equal असतील, it is called as a scalar matrix. So let's check out here, right? 4004. So diagonal कोणते आहे? This one 44. So these are equal. Then this one, right? सगळे 0 आहेत बाकीचे उरलेले, but the diagonal are equal. That is 8, 8, 8. Then it's a scalar matrix. Here minus 2, minus 2, minus 2, right? It's a diagonal. So you can take out these are also the scalar matrix. So scalar matrix means a diagonal matrix in which all diagonal elements are equal. It is called as a scalar matrix. Now unit matrix. Unit matrix ला identity matrix पण म्हणतात, right? So what is the definition? A scalar matrix. Scalar matrix काय बघितलाय आपण की ज्याच्यामध्ये diagonal चे elements same आहे and non-diagonal elements are 0, right? So a scalar matrix in which all diagonal elements are 1 is called a unit matrix or an identity matrix. So here it is always denoted by I. Remember this. Zero matrix कशाने denote असतं? Zero matrix is by capital O. Zero matrix, right? आणि unit matrix असेल, unit matrix म्हणजे काय? Scalar matrix with all diagonal elements are 1. The unit matrix किंवा identity matrix म्हणतात. It is always denoted by capital I. So here example, it's I2. Now it's a square matrix, so it is identity matrix of order 2. It is 1, 1, right? This is diagonal matrix. Diagonal is this one, 1, 1. These are same and it's a 1. So it's a I2, that is identity matrix of order 2. Then let's say I3, that is this diagonal elements, right? These are 1, 1, 1. and other are 0. So these are called as a unit matrix or identity matrix. Now second last type, that is upper triangular matrix. Upper triangular matrix, it means some square matrix in which all elements below the principal diagonal are 0 is called as an upper triangular matrix. So let's check out this one. इथे काय आहे ट्रायंगुलर राईट 4 2 त्याच्यावरती लोअर जे आहे दिस वन इट्स युअर डायगोनल 4 2 राईट and elements below. So principal, below principal, it means this one 0. It's a 0. It means it's a upper triangular matrix. Same here. Sorry, graph pattern change झाला है. Just a minute. Sorry for the interruption. Screen दिसतंय व्यवस्थित? There are some issues. So upper triangular. So here. So this is 0, right? The elements, all elements below the principal diagonal will be 0. So it will be like this. So these are 0 0 0. Same for here 0 0 0. Always remember, upper triangular matrix is always a diagonal matrix. Now it's a reverse of upper triangular, that is lower triangular. So lower triangular काय होणार? All elements above principal diagonal जे असणार, it will be 0. So let's see, take out the same here 0, right? Upper. So here 0. Here also all elements 0. So it's a lower triangular matrix. It is also always a diagonal matrix. Now symmetric. Now symmetric matrix. For symmetric matrix, a square matrix in which the elements are symmetrically situated. Symmetrically म्हणजे uppers मध्ये, right? So with respect to principal diagonal, म्हणजे principal diagonal जो आहे, the elements will be fixed in the upper triangular and lower triangular elements will be changed as per this order. So what is it? It is called as a symmetric matrix. So let's see with the example. So here these are same, right? So upper and lower elements are same, non-diagonal. Here 4 4, right? This is 6 6 and this is 10 10. So except your diagonal matrix, diagonal elements, non-diagonal elements will be switched symmetrically. It is called as a symmetric matrix. So same, let's see another example. That is this one is 409 जो आहे it's your diagonal. So diagonal आहे, उरलेले elements symmetric मध्ये आहे. 6 आहे, same 6 आहे. -9 is the same -9. Here 8, here again 8. So this is called as a symmetric matrix. Okay, and the last one is skew symmetric. The anti-symmetric plus skew symmetric. So a square matrix in which the elements are symmetrically situated with respect to the principal diagonal are equal in magnitude. म्हणजे value same असणार, but have opposite signs and its diagonal elements are zero. Diagonal elements जे आहेत ते सगळे zero असणार. नंतर सिमेट्रिकली जे असणार ते तुमचे value same असणार. Magnitude will be the same, but the signs will be the in opposite. So let's see the example now here. 9 minus 9, right? It's a 9, but reverse element is minus 9. And these are the diagonal elements will be the 0, 0. This one, 3 of 3 order, see, 4 minus 4. It's a minus 6, the second will be plus 6. Here 10, it's a minus 10. And the diagonal elements will be 0. Here 1 minus 1, 9 minus 9, 2 minus 2. So signs are changed and the diagonal elements are 0. It is called as a skew symmetric matrix. Okay. So thank you for today's session. Is there any queries you want to ask?